Hello everybody, welcome to Space Center. And today's video is going to be a bit different than normal. Because in this episode, instead of exploring the exoplanets of our galaxy, we're going to be exploring the dwarf planets in our own backyard. So first, let's go to the closest dwarf planet to the Sun, Ceres. Ceres was once considered an asteroid by many astronomers due to it lying in the asteroid belt. Ceres is like the most massive object in the asteroid belt, making up about 40% of the total mass of the asteroid belt. It is around 900 kilometers in diameter and about 1% the mass of the moon. It was discovered in 1801, and it has like water ice on its surface, as you can see right here. So Ceres has a lot of like, oh my god, huh? Uh-oh. I just got a flood warning. Danger in the life-threatening situation. Okay. Yeah, but I'm in a high up place. Like the place I live is like probably like 150 feet above sea level. And it's pretty far inland, but I'm fine. Yeah, I basically live on a big hill. Okay, so as you can see, Ceres has a large cratered surface. And it's made mostly out of, like, silicate. And may have a bit of water ice. Ceres was visited by, the Dawn mission. That mission basically scanned out the entire dwarf planet by orbiting in a polar orbit around it. For a couple of years, I'm pretty sure, or months. That's why the version of Ceres in Space Engine is so high quality compared to other asteroids. So let's go to our first and probably the most famous dwarf planet in the Kuiper Belt. Pluto. Pluto was once considered the ninth planet of the solar system. Until in 2006, astronomers discovered several other icy bodies orbiting at a similar distance from the Sun to Pluto in a region that we call the Kuiper Belt. So, the IAU decided to demote Pluto from being a planet to being a dwarf planet due to its small size and it not being able to clear its orbit of similar sized objects. Pluto is the only Kuiper Belt dwarf planet that we've been able to get good quality pictures of, as you can see. Unfortunately, the New Horizons mission that visited Pluto was only a flyby, meaning that only got good quality pictures of one side of Pluto. As you can see, the other side is all blurry. You can still make out some surface features like this big crater right here, but it's way lower quality than this side. So as you can see, Pluto has these large regions of brownish red terrain. This is because Pluto has chemicals on its surface called fullerenes, which are made when methane ice gets blasted by UV radiation from the sun. This creates these fullerenes which reflect the most red light of all the wavelengths. I'm moving over to the bright side of Pluto. You may notice, where are you? Here it is, Sputnik Planitia. Sputnik Planitia is basically a giant basin slash glacier on this side of Pluto. It covers a large portion of Pluto's surface. It's mostly made out of nitrogen ice, along with some water and methane. So as you can see, it's a heart shape, like this. It is theorized that Pluto got its moon Charon during a large collision between the two bodies, when they basically brush up against each other and slowly got into orbit of each other. And because of this, some astronomers call Pluto a binary dwarf planet system. Due to its moon Charon right here, not orbiting directly around the center of Pluto. Instead, both bodies orbit around a common center of mass between the two. Charon is Pluto's largest moon. As you can see, it's covered in really rough terrain. This rough terrain is likely due to the once liquid subsurface ocean of Charon freezing over, causing the surface to expand and crack. You may notice that Charon has some fullness on its north pole. This is likely due to fullness from Pluto getting blown off the surface and landing on the north pole of Charon. Pluto has several other small asteroid moons, like Styx, Nix, Kerberos, and Hydra. The next dwarf planet we're going to is Haumea, named after her Hawaiian goddess. Haumea is egg-shaped due to its extremely fast rotation. And you may also notice its rings. Haumea is the only dwarf planet known to have a large ring system, as you can see. Haumea has two moons, Hyakka and Namaka. As you can see, Haumea rotating super fast. Scientists think that Haumea got super fast spin from a collision with another dwarf planet or asteroid that hit Haumea on its side and sped it up super fast. Scientists also think Haumea might have some fullness on it too, due to there being some darker spots on the dwarf planet's surface, which could indicate patches of fullness. Next dwarf planet we're going to is Makemake. Makemake has one moon. The game I'm playing, Space Engine, doesn't really put Makemake to justice. Because in real life, Makemake is most likely extremely red due to a high concentration of fullness across its surface. Makemake is the third largest dwarf planet in terms of diameter, behind Eris and Pluto. It has an extremely high concentration of fullness, which in real life make it look extremely reddish. It has an orbital period of 300 years, which is a lot more than Pluto's 248 years, or Haumea's 282. Make is the second brightest object in the Kuiper Belt, just behind Pluto. It was discovered in 2005, a little bit later than Haumea, and much later than Pluto, which was discovered in 1930. Then we go out to Eris. Eris is the dwarf planet that really started the motion of Pluto, due to its similar size and larger mass than Pluto. Even though Pluto's bigger in terms of diameter, Eris has a larger mass, which is 0.227 times the mass of the Moon, and while Pluto is 0.177 times the mass of the Moon. Eris is extremely bright due to its high albedo and being made of a lot of nitrogen ice. And it takes around 560 years to orbit the Sun. And currently it's about 95 AU from the Sun, meaning it's 95 times the distance from the Sun than Earth is. Eris also has a large moon, Dysnomia, which is unique because Dysnomia has an extremely low albedo, which means it absorbs most light it gets, making it super dark and hard to spot, especially like contrasted against like extremely bright surface and reflective surface of Eris. Next, we have Gong, which is another dwarf planet that's in a similar orbit to Eris with high eccentricity, and it takes 548 years to orbit the Sun, kind of like Eris. Gong is named, I believe, after a Chinese god, and it has a surface covered in some Folin, similar to Make. Gong has one moon called, I'm going to mess up this pronunciation, Zhanzhou? Yeah, I have no idea how to pronounce that correctly. Zhanzhou, whatever. And it was discovered in 2010. It has an extremely low mass. Gong is, I believe, the fourth largest object beyond the orbit of Neptune that we currently know about, being slightly smaller than Make, and around the size of Pluto's moon Charon, as you can see. So, let's go to our final dwarf planet of today, Sedna. Sedna is an extremely interesting dwarf planet, being covered in Folins like Make and Gong. But it's much smaller than the other dwarf planets. But what makes Sedna extremely special is its extremely elongated orbit around the Sun, which takes a total of 12,660 years to orbit the sun once. That's insane. Meaning that the last time that Senna came by the sun, it was still the last ice age. Like, that's crazy. Like, the last time it was in the position it wasn't now, the last ice age was coming to an end. That's just crazy. It's just insane how in just one orbit of this dwarf planet, we have gone from basically hunter-gatherers to being able to land on the surface of the moon. 6 times. That's just insane. People think that Senna got to its extremely elongated orbit because of a hypothetical planet called Planet X, which is a planet that could be around the size of Neptune, or smaller, being either sub-Neptune or super-Earth. As you can see, I installed a mod space engine that adds it to the game. As you can see, this Planet X is about 600 AU away from the sun, taking 17,000 years to orbit. And also, scientists, they think this planet exists because they've noticed that many, like, scattered disk objects and, like, other objects in the Kuiper Belt and beyond have orbits that have been elongated out thousands of AUs from the sun, going into the inner Oort cloud, which is like a sphere of icy bodies surrounding our sun. So like comets like this one that sit like extremely far out in the Kuiper Belt. We have no current way of reaching this Planet 9, but we do have the current chance to detect it using like observatories like the Vera Rubin telescope, which just came online. Meaning that if Planet 9 is in the southern hemisphere relative to Earth, if Vera Rubin keeps observing there, which will for 10 years, it could actually detect Planet X due to its extremely powerful and high quality digital camera. So anyways, everyone, that was the minor planets of the solar system, the dwarf planets. I hope you enjoyed this day's video, and goodbye.